My name is Hari Krishnan. I welcome you all to this talk. Thank you for coming. So this is a talk about API design first and practice. Quickly about myself. I am a transformation advisor. I do a little bit of coaching and training, and primarily API governance strategist. So that's quickly about me. And those are some of the conferences that I speak at and volunteer at. I love communities and conferences like this one. And of course, it's great to see you all. All right, so let's get right into it. So if I'm talking about API specifications and API design first, the first thing that comes to my mind is this term called executable contracts. And what do I mean by that? So given I have an API specification, we could feed into this tool called Specmatic that we built, and we can generate service virtualization out of it, contract as a stub server, and which means the consumers can start building straight away from that stub application, right? And likewise, the other side of the coin, when you take a specification, is I should be able to generate tests out of it and run it against the provider of the the API. If you have these two sides, then you have a complete picture in terms of having to isolate the consumer as well as the provider, not having to put them together and verify them together. Rather, they can be they can independently parallelly develop. How do we go about it? I'll quickly jump into a live demo before we can come back, zoom back out, and look at the approach itself. So getting into demo here quickly. So I have an API specification, Open API. Most of us are all familiar here. I'll pull up an outline of this specification right here. It's got a bunch of paths, and of course, it's got schema definition and all these routes. Now, what do I do in order to get this into a service virtualization setup? The first thing is I could start with starting a stub server. But before I do that, what is the data that the stub server is going to serve, right? It needs to have some sort of a stub data. So for that, I would like to generate some examples based on the API specification and go from there. So let me quickly kick off this command here. It says interactive examples for this particular API specification. And it's given me a link which I can launch. And I'll launch it up here. I'll go full screen. And these are the exact same paths that you saw in the API specification. So what we've done is teased out all the endpoints from there, put it in here, and say what is available to generate. So for example, I'll take this find available products, this endpoint. I'm going to generate an example. Let's look at what that example looks like. So there's an HTTP request and then HTTP response part to it, standard request response. So the request has a bunch of parameters and the response has a bunch of values. You might be wondering, the API specification itself did not have any data inside of it, right? No examples. Where did all this data come from? It says iPhone 16 Pro, Platform Summit Special Edition. Where did this information come from? So this is coming from the fact that in my command, if you notice, let me make this a little bigger. Yeah, hope it's visible. So this dictionary here, which I'm passing to it, I'm giving it a bunch of data which is relevant to the domain. I'm telling it whenever you find these particular domain entities and you have to give a value to it, you can look it up in the dictionary and put it up into the example. So that's how the data came up, right? So now this is great. Once you have the example, am I already done? Can I start a stub server? Maybe not. First, I want to validate it, right? And it says it's a valid example because I just generated it from the spec. It's all clean. But this is not what I would work off of, right? I would like to make some modifications. So as a dev, I'd go in, I'd look at the example folder that got generated here. I'll minimize it. I'll open the example file. I'd like to change a few things. So I'll say page size. I just want that arbitrary number because I didn't give an example. So I'd make it 10. What's the data coming back here? It's iPhone. So maybe the type, I'm just going to say it's a phone, and I'll save it. I'm done with that example. Go back to my UI. I'd say validate. And it says it's an invalid example. Let's look at what's the issue. It says specification expected, gadget, book, food, or other, but I gave an example that contained phone. Now, example validation is a super important aspect because API specifications by themselves give a certain amount of information. But beyond that, when the examples go out of sync, consumers of that API get impacted very badly. So that's where this check is important, and because the API specification says that this is an enum, you see it here. So what we've done is figure that out, that it can only be one of these values, and it's validating that and fixed it. So let me fix the example now to say, I'm going to say it's a gadget, done, and then I validate. It's good, we are good to go. So now that the example is available, I'd like to exercise the example, right? I want to see the data come back for the stub server. What I'll do here is go back to my README. I'll kick off the second command, which says start the stub server with the same API specification. Now it's going to use this example file, which I just created from the UI, and I can go to my Postman and hit a send, and I get back the exact same data which I set up in my example. So this is the part of the diagram which I was showing on the left-hand side, right? When you have an API consumer, the moment you have an API spec, I can already create a service virtualization server. And this is truly representative of the spec. The examples are always validated. So that safety net is there for the developers who are using this API, right? So that's the first part. So what next? I've already done the stub server. Can I run a test from this? I already have the example, by virtue of which I'm serving the response. Can I take the same example and fire off a request to a provider? Yes, I can. I already have another application here which I've booted up and running. It's a Spring Boot application. It doesn't matter. We are completely over HTTP. I go back here, and you see the only switch here is instead of stub, I'm calling it test. I'm going to say it's running in port 8080, and I hit go. It ran a bunch of tests, and you will also notice, which is like 16 tests, 14 successes. Let's look at this in a more readable format. So you'll see that there's a new build folder that came up here, and there's a HTML report, nifty little report. I can go in there. It's the exact same endpoints which you saw in the OpenAPI specification. These tests were generated straight out of the API spec and the example that we generated, right? So to prove that, I'll go into this particular endpoint, find available products. I'll look at this particular request response which happened between the test and the actual application. And when you look at it, it's the exact same thing. The request went out with page size 10 and type gadget, and it got the response back. It validated it against the contract to see if the schema is the same. So this is the two sides of the coin that I spoke about. Now that we're done here, let me quickly jump back into my slide. So this is a recap of what I just did. I took a spec, I ran it as a stub, I ran it as a test, and I made sure that the examples that I'm using for my stub and test data is exactly according to the API specification. That's a super important DevX that's important, right? So let's go further down. Now, if API specifications are so critical to our everyday operation, then how do we go about starting with our API design first approach, right? Who are the people who are involved? So in our case, we had the API consumers, the engineers from that team, the API providers, the architects who need to work with making sure the organization is consistent across its API design. Then we have, of course, the AppSec people. The security is as important as everything else. So all of these people come together as a group, and we want to collaborate on the API design. And usually how we do that is we have that discussion and we put it over a wiki page, or we put that in an email and share that with each other. That's not perfect, right? So we want to do that agreement and then put it out into an API specification. I was showing you an example with OpenAPI, but then you could do that with anything, right? It could be even type spec. Some of the people were talking about it today. So once you have the API specification, that's like an unambiguous representation of what we agreed, right? This code is like easier to understand and it's machine parsable. There's no two meanings to it. You put that down into your API specification. Then whoever needs to build out of it, the consumers as well as the providers, they build out of it, and their interactions are governed by that API specification is what we want to achieve, right? So this is the next step. Now, considering, again, API specification is so crucial, where do you want to store this? Where do we keep the API specifications? Some people might say, I want to keep it with the provider because I code gen or spec gen from my API specification from the code. So probably I'll just serve it over Swagger UI. You take it from there. But that's probably not what you want, right? Why? Because we want a democratic look at it because you want it to be on common grounds between the consumer as well as the provider. So what's the best place to store it? We figured, why not Git? It could be inside a broker or something like that, which makes it difficult because I had to worry about another, something in the critical path that I have to stand up and maintain and serve. Git is always there. We as engineers, we are familiar with the Git ops and the Git workflow. We just take Git. And how do you get the specification into Git? A central contract repo. You go through a regular pull request process. You get your linting. Most of you are familiar with that, with vacuum or your Spectral, your tool of your choice. Next comes the backward compatibility testing. This is really important because when you have an API specification, I want to figure out if I'm making any backward breaking changes as part of my design phase, right? How can I do that? So this was an accidental discovery. I already showed you that the API specification can be used to run as a stub or a test, right? So the clever bit that we got here is I could take the new version of the API specification, which is in the PR, in that branch of the PR, right? I take that, I run it as a stub server, okay? And then I take the existing version of the API specification from the central repository, run it as a test against this stub server. If all the tests pass, great, your change is backward compatible. If not, you've identified an incompatible change, and you can stop right here and figure out if you want to version bump or you want to make the change in a backward and compatible manner. You've not written a single line of code at this point. All of this, the stub, the test which I've shown, and the backward compatibility is completely no code. So this is super important for developers because they're already hammered with a lot of responsibilities. They need to churn out features, and they cannot sit and deal with other stuff. So that's where a no-code solution is important, and this sorts out a lot of problems for people, right? So once you have this out of the way, your backward compatibility testing is done. Of course, you get your SecOps, get your security scanning and whatnot in terms of the patterns of design you've applied. Is there any vulnerability there? Get that out of the way. And a review. Have a committee or have a group of people who need to figure out whether this change is fine. And then you merge it, review and merge. That's pretty much it. You've done the entire journey. This is a very, very familiar Git workflow that most of us have. And you have traceability in terms of what are the changes that happened. Now, let me give you a quick demo of this backward compatibility. And just for variety, this time around, I won't use OpenAPI because we're all quite bored of it, I guess. So let's look at something interesting. I'm going to use backward compatibility with Proto files. So let me close all of these. I have two Proto files here, V1 and V2, product. Just a description of a bunch of operations on a product service. And just so you believe me that these are indeed identical, they are absolutely the same copy. So the first thing I'm going to do is verify that if there are the same files, they should be backward compatible, right? So let me quickly pull up my command. I'm going to run this. And as expected, you get the verdict that everything passed, all changes are backward compatible. Now let's do something interesting, right? Let's take version V2 of the Proto file, and I'm going to add a field, which is, this is a new product. It already has a name, it's got a type, it's got inventory. So what I want to do is probably add a description. Let's say, yeah, and thank you Copilot for doing that. I make that a mandatory field. Is this a backward compatible change? Quick yes or no? No, right? So let's verify that. I will clear this, run it again. And right on cue, it's a backward incompatible change. So this is an easy one, right? Because if you add a mandatory parameter to the request, and the tool is telling us the same thing, and you see the error, if I go to that, it says description was missing, but it's expected, right? So you get that detail. I haven't written a single line of code yet. I'm just working off of my Proto files at this point, okay? So let me clear this. Let me do something more interesting now. Let me undo this change. And there is a range here. The inventory can be between 5 and 10. So I'm going to reduce this and make it 8. Is this a backward compatible change? No. And like the gentleman here said, it's because you're contracting the contract, right? You're reducing what's acceptable. So let's figure out if we are able to identify this issue. Fail. And likewise, when you look at the error, we are trying to test here based on the boundary. So what we do is we use the specification as a feature, we derive properties out of it, and we are trying to do property-based testing here on that particular proto. And we figured out that if I send it within the range, it has to be acceptable. If it's not, it calls out the issue. So that's what we've done here, right? So that's a quick demo. Again, you might have noticed I'm using Proto validate with Proto 3 because Proto 3 itself is completely optional. It doesn't have any validations. If you want to talk about it, I'd be outside and you can catch me up and I'll have enough of a rant on this. Since I'm limited on time, I'll further move forward. Okay, going back to my slides, let's put all of this information together, right? This demo that I just showed you, this piece, we've also set it up on, these are screenshots from my GitLab, but you could do it on GitHub Actions, or you could do it on Azure. Tool of your choice, doesn't matter. The approach matters. So here we have a lint that's passing, the compatibility that's failed, and that's the kind of error message that you would get in your pipeline, and thereby your merge is blocked. So you cannot even get in a backward incompatible change into the central contract repository, which is your source of truth, right? So that's the critical piece in the experience, as well as in achieving API design first is our belief. Moving forward, putting all of this together, what does it look like in a nutshell? Again, recap, I have the API design first. It goes through to the central contract repository. It's the source of truth across all our consumers and providers. And the way to get in there is your pull request mechanism, where you lint, you do backward compatibility testing, and then you verify the, go through a review process, your SecOps and whatnot, get that in there. Once it's there, then you feed that to Specmatic. The consumer can spin up their own stub server. That's the first demo that I did. The provider can use it as a test, which is the second demo that I did. I could directly start running tests. No matter how many times we tell, it's very hard to write tests considering to the level of effectiveness and fitness that we want, right? So that's where if you're generating your tests out of this, it's a beautiful way of doing it. We also do something called API resiliency testing to figure out the edge cases. When I said property-based testing, we also mix in a little bit of mutation testing concepts there, and we verify all the edge cases. So if you're interested more in that, I would request you to all attend the talk by Naresh here. He's sitting. The talk is at 2:20 p.m. in this very same room. We'll be talking about resiliency testing and go into more details there. And about the consumer, because I can do service virtualization based on the spec, I can do a lot more fault injection and all of those pieces also there. Now, these two pieces have independently started working. And like I said, it's important to understand that testing and stubbing are the two sides of the same coin, which is the contract. And that's the currency we want to maintain. Now, when you take that, you can also do the same thing in your CI server, because spinning up a stub server was like practically just an executable run on my local machine, right? So the same thing would run in your CI. Doesn't matter what tool of choice you're using, it's all the same. The approach matters. Now, when you go there to the provider side, I'd again do the contract testing in my CI and get the feedback there. So worst case, ideally the developers would be able to get their feedback on their local machine. They don't need to be on the wall of shame with a broken build, right? But but if you do get there, there is a fail-safe, right? It's going to catch and help us out. Now, all through this while, the provider and the consumer have never tested together with an integration testing sort of environment, right? But they're still quite integrated, because Specmatic is making sure that it's doing the arbitrage and making sure both sides of the the API boundary are adhering to the agreement, which is the API contract that they agreed to. And once you do that, when you go to integration, you're not going to have a lot of surprises. It's going to work pretty much butter smooth. And from there, you have a clear path to production. So this, in our opinion, is a API design first sort of experience that we put together. And the DevX around this is very, very important, because when you shift left all the way to the left, all the way here, you're not even letting the situation proliferate further, where you let an issue get incepted here, then go all the way to coding, and then realize that it's breaking something, and then you have to come back and rework. You don't want to do that. You want to find it right in this green region. That's the heat map. Anywhere there is crimson, you don't want to get in there. So shift left is what we're trying to do. The next piece we're talking about is the enhanced DevX. As a developer, when I say API design first, people might think that, oh, okay, it's like, it's not an evolutionary practice. Someone's going to write the APIs first, and then I'm just going to follow it. That's not the case. This is exactly important for an evolutionary design situation, right? As the API specifications change, you have to be able to get feedback. So I'll stop right away. Of course, this leads to reduced time to market because of the parallel development. And you could build resilient API building blocks. And with that, I'll leave you with this diagram. And my name is Hari Krishnan. Thank you very much. I'll stop right there.